4.7. Explain that the amplitude of the signals given out when processing nuclei relax is related to the number of nuclei present. When the nuclei are subjected to a strong magnetic field, some precess parallel to the field, whereas others precess anti-parallel. So normally there are more parallel than anti-parallel alignments, or precessions such as a net magnetic vector aligning parallel to the external magnetic field results. We've discussed that several times in my previous videos. So this is known as net magnetization. So when the nuclei are subjected to pulses of radio waves, the parallel alignments will absorb the energy and move into a high energy anti-parallel alignment. At the same time, the anti-parallel alignments will simultaneously readmit their energy to return to parallel alignments. In responding to pulses of radio waves, there are more nuclei changing from parallel to anti-parallel compared to reverse, and we've learned that in our previous videos. So there's more parallel going to anti-parallel than vice versa. The overall result is that net magnetization vector gradually rotates away from this parallel position to an external field line and eventually reaches the position that is 90 degrees to the field lines. So the net magnetization vector into the horizontal plane is known as transverse magnetization. So while the M vector is in the transverse plane, the precession of the nuclei are all in phase due to the action of the external magnetic field applied by the MRI machine. So this induces electromagnetic force in the receiving coil to form magnetic resonance signals. So when the radio waves are switched off, all the nuclei return to the original alignments and readmit the radio waves as they do so. This is known as relaxation, and which has two aspects, T1 or T2, and I'll discuss that in my next video. So the key things here is that you need to know is that hydrogen atoms or atoms in your body will possess more parallel than anti-parallel. When there is a strong magnetic field, they will align themselves into that arrangement. And then when we have a radio pulse or radio waves emitted to that area of the body, they will move into a higher energy state, or most of them will end up in a higher energy state in an anti-parallel alignment. So as they move into anti-parallel alignment, they will then change from anti-parallel back to parallel when the machine or MRI machine is switched off. They will then give off a radio wave, and then in that turn we can determine where and what composition of that target area was by T1 or T2 relaxation, and I'll go through that in our next video.